Hello everyone, my name is Alex Giles and you're here for the webinar Why Won't My IFC Files Import into Advanced Steel? So let's give you some information on that and go through what we can do with them. First of all, my name is Alex Giles. I've been working as a structures consultant at Graitec for around 10 years now. I originally trained as a mechanical design engineer and designed machinery for the steel and aluminium industries for about 10 years. When I moved sideways to become the CAD manager, looking after the users there, training and giving support on their various CAD systems that company used. And then I was made redundant there and came to Graitec, where I've been for the last 10 years, working 100% on advanced steel. So I've got about 20 years experience on support and training. Why should you use Graitec as your partner in the industry? Graitec are unique in being able to offer products and expertise in all areas of the life cycle of your products. And we like to split that into 4 business areas. First of all, we have Graitec Create, where you use Autodesk software enhanced with Graitec Power Packs to create the designs for your products. We have Power Packs for Inventor, Volt, Revit, and Advanced Steel. Then once you've modeled your product, you need to check it's going to really work, so you can use the Graitec Simulate, where we have state-of-the-art Graitec software to analyze your product, check the stress loadings and everything else, and make sure it is really going to work in a real-world environment. Once you're happy with your final design, you need to manufacture it, so you can use Graitec Fabricate. We have tools there and software there that can manage your entire workshop. All your resources in the workshop can be managed. We can scheduling the time for the humans doing the welding and so on, and we can shuffle CNC files between different types of CNC machines, scheduling them, interpreting the files, making sure the right data goes to the right place and everything's available. And of course, as I've just hinted, everything of those 3 creates lots and lots of data. So we have Graitec Manage, where we have software there that can help you manage all of your internal work in progress data, controlling your intellectual property and taking good care of it, make sure everything's up to date, everything's right, all the way up to the point where it leaves your company and goes to an external data environment. This particular webinar is one of a series. As always, we do many webinars. You missed the one on Friday last week for modeling the existing environment, but as you can see, there's a couple coming up in the next few days, which you might also find interesting. And there's a link at the bottom here for registering for any future webinars. These slides are available as a handout. If you look at your go-to webinar panel on the right of your screen, you can download the handout. So all these links will be active and live in those handouts. Please register for the other webinars. I'm sure you'll find them interesting. If you have missed any webinars, then all previous webinars we have done for years are available and linked to on the Advanced Steel Content portal. This particular webinar will probably pop up within the next 7 to 10 days on that portal, but everything we've done for years is on there. There's over 30 hours worth of instruction there. We also regularly publish blogs for Advanced Steel, lots of hints and tips, lots of supplementary information I'm sure you'll find useful. Some of it's really quite important. We get asked the same questions on support all the time, so we put them up as blogs, how the answers work. So if you haven't already done so, please follow that link and subscribe to the blog and look back over all the existing blogs. I'm sure you'll pick up lots of useful information. We recently did a BIM Up conference. We had one in 2019. We've done the one this year a couple of weeks ago. And there were over 270 classes in different subjects, in different languages for all over the world. At least 28 of those classes were for Advanced Steel. So again, there's massive data out there available to you for the asking. If you're a Graitec customer, you need to log into the Graitec Advantage site. Go to graitec.com to start with. And once you're logged in there, you'll be able to see the videos and watch any of those recordings from the last 2 years' conferences. And finally, if you're a Graitec customer with a support contract with Graitec, then you are entitled to have access to the Advanced Steel Power Pack. Or if you're supported on one of the other products as well, you can have the Power Pack for those other products. So please make sure you investigate that. Make sure you've downloaded and installed it. It's lots of extra tools for Advanced Steel, bells and whistles, nothing that's super critical, but lots of things that will improve your efficiency and make you much easier. So check that out and make the most of what's available to you. So today's subject is IFC files. What are they all about, first of all? Well, IFC. IFC stands for Industry Foundation Classes. This was a concept created by Autodesk in 1994, where they were looking for a way to have the same data used by various different bits of software. And they created a consortium of companies, which originally included 12 different companies, not just Autodesk. You may have heard of AT&T or Honeywell. They're fairly well known, among others that were part of that group. And originally they called themselves the Industry Alliance for Interoperability, but eventually that group grew. It opened its membership up to anybody who was interested, and it changed its name in 2005, so that now IFC is controlled and maintained and developed by a totally independent company or consortium of companies called Building Smart. It's no longer solely controlled by Autodesk. It's called Building Smart. It's independent, with Autodesk having a membership, so they can develop something that will suit any software, and that's the theory. And the IFC file format has actually been registered as an official ISO standard. Got the number there for quite some time now. So that's definitely a publicly published open format. Anyone can look up how it's written and read and write those files. So why are they used? Well, originally IFC was intended as a neutral file format, so you can share information between different 3D modeling systems. And that goal still remains the same. So as such, it forms part of many BIM workflows. Building information modeling is essentially all about transferring intelligent 3D models between different systems. The governments around the world have bought into this BIM concept, and many of them around the world have passed what we generally know as BIM mandates. The UK did, it passed one formerly known as the BIM Level 2 mandate. It's now called the UK BIM Framework. There's a website there which will tell you all about it. So basically any project you do vaguely related to the government or civil service in this country, in the UK, must be BIM Level 2 compliant, and that will describe what the minimum requirements are. And IFC can be part of that BIM workflow. But IFC is only one possible format that can be part of that BIM workflow. You can use lots of different formats, including SMLX, CIS2, SDNF, or COBie. You may have heard of some of those. What is inside an IFC format file? What is it? Well, it's an open format, but it's a very complex format. That ISO standard, or the full definition of the structure of that file, is hundreds of pages long. Very complex and confusing. There are lots and lots of data categories inside that file. I think I read somewhere 700, but I couldn't swear to it. But it's actually just a text file. You could open it in any text editor like Notepad++, as you can see in the image there, and it's full of gobbledygook, text and numbers. Not very exciting, not very easy to read as a human, but that describes all the properties of the objects in your model, so they can be read and understood by other things. But to read it and make sense of it needs a special bit of software. So you can't read it. I mean, Notepad can read it, but it can't make any sense of it. It's just text. To make it into a 3D model again, you need to understand what you're reading. So what could you use? What is this special software you could use? Well, there's actually quite a lot of free viewers available. If you search the internet for a free IFC viewer, you will find quite a lot. My favorite ones that I use, there's one called FZK Viewer. That's developed by, I think it's a Russian university. Works very well. There's also one called Solibri Anywhere. Does a nice presentation, nice view. There's Trimble Connect. Formerly, you could get Tekla BIM site. You've probably heard of that one, but it's now called Trimble Connect, or superseded by Trimble Connect. And there's DDS CAD Viewer. Each have the pros and cons, but those are the ones I favor most. In fact, if you go to this website, you'll find a whole list of lots more different free viewers you might want to download and try. They're all free. Give them a go. I like these four. And any of these programs can help you open the file, see a 3D model, and understand what's inside. So what's the big problem with IFC? Why is it, we've said its goal is to change data between different software. Why isn't it working? Why can't you import it? Well, there's a number of problems with IFC. The first big problem with IFC is that it officially allows anybody to create their own custom data fields. But remember, this is about exchanging information with other people. So if the exporter creates custom data fields, how's anyone importing supposed to know what that field means? or what it represents. They're not going to understand any custom data, so those fields don't really do anything useful to share with other people. As such, I think that defeats the entire object of having a common neutral format because other people can't read it. Tekla, for example, one of the main competitors to Advanced Steel, create lots and lots of custom data in their IFC files. Here's a screenshot. Let me show you one. Any of that custom data cannot be read by other systems. It will just be ignored and not imported by any other intelligent system. The FZK viewer makes this easier to see. So let's see if I can switch to that. That's that one. So here we go. Got a nice looking model here. You know, nice big shed with a mezzanine floor. If I select any object there, I don't know, let's go for a beam here. Right, and look at the properties. Tekla. Although these properties might sound useful, net weight, net volume, assembly weight, preliminary mark, phase, part mark, none of those will be of any use or can be imported by any other software other than Tekla because nobody else knows what those fields are. Tekla made them up as they went along. So one thing you will find is that certain programs write a lot of the data into custom fields because they can't work out the standard fields. But the second biggest problem, maybe I should have put it first because it's the biggest problem with IFC files. IFC files can represent components in the file in several different ways. They can have solids and swept solids and all sorts, but one of those ways it can represent it is called BREP, or boundary representation. And that's basically just a pretty picture. They're the easiest way to create data for an object in the file, and they can be used for absolutely anything in the file. Even if it's a custom object that makes no sense to anybody else, you can create it as a pretty picture. They know what it looks like in whatever the exporting software is, so they can create a pretty picture of it in that exported file. But they don't know how to describe it officially in any intelligent way. So a lot of programs default that their export is always just going to create pretty pictures, or BREPs in all the exported files, because it's just so easy to create. They haven't got to think about categorizing and adding intelligent data. So they just make a pretty picture of everything, and there you go. So unfortunately, because it's just a pretty picture, a BREP does not contain any useful intelligent data. Okay, no intelligent data. It's just a picture of the object. If it's got no intelligent data, that means you cannot import it. The easiest way to see any files with BREPs inside them is to use one of the viewing software. So Solibri Anywhere or FZK can see what they look like. There's a picture there. Let me open and I'll show you that in Solibri. So here we go. This is the Solibri Anywhere viewer. Very nice. I can pan and zoom. Nice little model of a building there. Looks like some interesting stuff inside. Let's see if I can get to that. So maybe I can select the wall. Let's turn off. Oops. Turn off the walls. Turn off the windows. There you go, lovely looking bit of stair there. I want to import that into Advanced Steel. Let's select a bit. And as soon as I select it, look over the left here, and it says very clearly it's a boundary representation. If I attempt to import this file into Advanced Steel, there's absolutely nothing in this file that can be imported to Advanced Steel, because it's everything 100% is boundary representations. Looks lovely and pretty in a viewer, completely useless for import. Or if you try the FZK viewer, you can also see there when things are BREPs. So back to the FZK viewer, same file, same beam I've got selected there. If I go to the element properties page and find geometry, it says there BREP. So again, that makes it clear. If that's a BREP, it's not going to import. Looks like a lovely steel model, you know, all steel, everything in there, isn't it? Nope, there's everything in here is BREPs. Nothing is going to import. So, like I've already said a couple of times now, they're just pretty pictures if you have BREPs. Some programs like Revit can import the BREPs as a pretty picture, so you can see it, but they have no intelligence even in those programs. They can't. It's not going to be a beam. It's not going to be a bolt or a column. It's just going to be a blob. Advanced Deal can only import intelligent solid objects. It cannot import BREPs. So therefore, although those last two files look great in the viewers, they contain nothing that Advanced Deal can import, because everything in those files is 100% BREPs. And you will be left with a completely empty file after you try and import that IFC. It's not Advanced Deal's fault. There's no intelligent data, and therefore nothing of much use to Advanced Deal. So what causes this issue? Well, often the exporting software, whether it's Tekla, Revit, or something completely different, STS2, who knows what else, they have options you can play with. Not always, but often they have options you can play with. And it may be possible by selecting different options from the default to tell it or force it to import intelligent data rather than exporting BREPs. It might just be a single option. You might just have to choose a fabrication model instead of choosing design model or concept model in one single drop down, whatever it offers you there. Or it could be lots and lots of technical settings. Tekla has pages and pages of settings with lots of settings on each page. We use Advanced Deal, we don't use Tekla, so I haven't got a clue what most of them mean. We can't work out yet, or haven't yet been able to work out the optimum settings for Tekla to force it to export intelligent solids. We know it can be done. I've received IFC files from Tekla that have imported pretty well, but you have to get all the settings just right, and unless the person exporting does the job carefully, 99% of the time they just be reps. So you have to ask the other person, the third party, very nicely, please can you look at your options, and please can you try and choose fabrication model or choose some options that force it to export intelligent solids, because I can't read BREPs. They probably won't understand what you're talking about, so you might have to explain some of this to them. But once that IFC file is written, the damage is done. There's nothing you can do when importing to turn a BREP into anything intelligent. You can't edit the file, you can't recover the data that's been lost. It's just a picture, all the data's gone. The damage is done when the IFC file is written. It's all down to the person doing the exporting. So what on earth can you do if you've got a file that's full of BREPs? Well, there are a couple of options. The first thing to remember is you cannot ever get intelligent data from a BREP file. It's just going to be pictures. But what you can do in various ways is get a model or a representation of the model to show us alongside your structure, or along trace over with new beams to replace the pictures of beams in your file. So you can get a picture of the other file in your file. There's various ways you can do that. One option, and the reason I like the DDS CAD viewer, is because it can export as DWG. So let me quickly show you that. That's that one. So it's not my favorite viewer, but having just opened that same model you saw in the FZK viewer, I'll go to the File menu, Export DWG. And that gives you a DWG file, and everything in there will be replaced with solids. But there'll be solids inside blocks. So once you've done the export as DWG, you need to open that new drawing and select everything and explode just once, so it becomes solids, not blocks. Once you've exploded that once, you can save and close that file, and then you've got a safe model file, and I recommend you insert that into your current model, either as a block or as an XREF. Don't insert it all or import it straight into your file. You don't want hundreds of individual pieces. You're better off having it all as one lump, an XREF or a block that you can remove easily later on. But you can still snap to the ends of it, even if it's blocks and XREFs. So that's DDS CAD viewer allows you to export as DWG. You can open that, explode everything once, save it, and then you can use that as a block in your file. And this is what it looks like in Advanced Deal. Pretty good. Everything's there. Another option would be to use the FZK viewer. It might not be the prettiest viewer, but it does have the option to export as step files. So let's just show you that. Again, here's the file. Nothing in there is intelligence or BREPs, but I can go File, Export, Step. And then with that step file, I can import that into Advanced Deal using the standard AutoCAD import other formats command. That will import it into a blank file, or into whatever file you got open. Again, I recommend you import it into a blank file, which you then insert as a block into your current model. And there it is. The downside is that's all one color, all on one layer, whereas the other one had it look a bit more pleasing cosmetically. The final choice, if you have it, they have two bits of free software, DDS CAD Viewer and FZK Viewer. But if you have Revit available, because you have the AEC collection, you also have the option to open a new project in Revit, use the link IFC command, so import your model and the IFC file. Then you can export as DWG there. And that will create two DWGs, one for the project, which will be empty, and one for the IFC. And then if you insert the one which has the longest file name, the IFC one, into your DWG model in Advanced Steel, you don't need to explode it or do anything else. It's already ready to use. And again, as long as you make sure everything was visible in Revit, there you go. There's your imported model in Advanced Steel. So all those three techniques will allow you to get a picture of the IFC in your Advanced Steel. That looks great. None of those are steel beams. That is an Advanced Steel screenshot, but none of them are intelligent beams. They're just 3D solids. But you can snap to ends, you can put your steel work next to them and so on. So it depends what you need it for. It's better than nothing, which is the alternative. Okay, but we want to actually import the IFC as intelligent data. So let's assume you have got an IFC file that's got some intelligent data in it. Well, there's very few options, or basically there's no real options about how to import, but you will be asked about mapping when you import. When you do that, you've asked all the questions for mapping. Basically, you just have to take what you get. There's nothing we can do. Again, there's no options. So I can't try again and do a different option to get a different result. I'm just going to get what I get, take it or leave it, like it or lump it. That's it. Whenever you start an import, the first question is, which application did it come from? It's tempting to try and look in there for a different answer, but we've tried that. It doesn't seem to do anything or work properly if you change that. So just leave it on Advanced Steel and say OK. What's the mapping all about? Well, of course, to a human, if I read that, UB254 space big X space 102 space big X space 28, and I read 254 little x 102 UB28, that I recognize those instantly as being the same beam. And I barely even register that they're different. But to a computer, those two strings are entirely different and have no resemblance to each other at all. So you have to tell the computer this equals that. Each bit of software probably names the same thing in a slightly different way. So you constantly have to tell the computer this name equals that name, this name equals that name. And it will be able to match up the objects. You must answer every single question. There always seems to be a lot more questions than you expect. You think it's only a small model with 20 beams. How can I get 50 questions? But don't argue with it. You just have to answer them all anyway. Persevere. You might get asked about materials. Here you go. This one says structural steel, S275. But that does, so we have to say that's just plain S275 in our list. Or it might be the section size. This is UB356 by 127 by 33. And we've got little X's and that. So we have to choose the right one off the list here to map the right beam size into Advanced Steel. Each time you do a mapping, you might say, I'll choose an option and say, OK, it's remembered from then on. So you only have to do each name once. But because it's remembered, you should never guess what the mapping is, and you should never use a supposedly temporary mapping, because the mapping is permanent, it's remembered. So your guess or your temporary one is stuck until you reinstall the software. It's very, very hard to find and remove it otherwise without reinstalling the software. So you'll always have it importing as the wrong thing forevermore. If the correct answer isn't known, then you should click ignore. So here we go, there's a picture. It's asking for material, but the material is blank. Not quite sure what's going on there. It might be a bug. We've asked Autodesk, but that does happen. You get blank for the beam name or the material. You can't obviously map that to anything sensible, so you have to click ignore. This name, plate 15. 15 by what? 100 wide, 200 wide, 500 wide, who knows? You can't map that to anything useful. So again, you have to click ignore. And generic names like supporting beam, mild steel, you can't really map them because they might be different on the next project. So you have to click ignore. Sadly though, if you click ignore, it's not remembered. So every time that entry appears in the IFC file, you're going to have to click ignore again and again and again. And if you get carried away, it's very easy to click too many times and click ignore on something you could have mapped as well. When you do click ignore, it's not going to import that part. The results you get, they could be okay. They might be really nice, but they're likely to leave quite a few things to be desired. We estimate if you get more than 70% of the data through correctly, you're doing pretty well for any import. Sometimes you might get 80 or 90% of the data, it depends on what the data is. But anything over 70%, you should basically consider yourself as done quite well. But that's it. That's as good as it gets. We can't do anything about it. The software is what it is. It's a very difficult technical issue to map one thing to another and to share this data between different software. And like I say, IFC's existed since 1994. Autodesk have been working on it for that long. And it's still very difficult. Graitec can't do anything on the import that you can't do. There's not really any point in you sending us a file saying, I can't import this file. Can you import this IFC file for me? I can't do anything that you can't do yourself. All I can do is open it up, do the mapping when I can recognize the names, say ignore for everything else, and I get what I get. It's just the same as you will get what you get. Usually, if it's not importing, it's probably because it's B-reps, but if you think there's intelligent data, you've checked with the viewer, no, it doesn't say B-reps, so it should be all right, then it's going to be up to the mapping. What you get is what you get. Let's have a look. Let's try and do an import. Here's Advanced Steel. Import IFC. And I'm going to import this one, Project 2, open. So let's see this in action. So here we go. The first question, as always, is what application was used? Well, I'm not going to change it, however tempting it might be. I'm just going to say OK. And it starts reading the file. Watch the progress bar at the bottom right. Hasn't got anywhere yet. Structural steel S275. So I'm going to have to map that down to S275. There you go. Okay. And it won't ask about structural steel S275 again. Then I got an I-beam, so it's a UB356. Now this is quite a small file. I'm going to do the whole import, even though it's going to take me quite a few questions. 12733, where am I? 356, 12733. Okay, just so you can see what's involved. UB254, 10228, that one. Okay. PFC, so let's change the channel. UK. Be careful you don't accidentally keep mapping everything to the Chorus Advanced ranges, because they seem to be at the top of the list. Make sure you choose the general range if you can, it's better. You don't want to always have the Chorus Advanced option. Oops, blank name, no idea, ignore. RHS, so rectangular hollow section. Yeah, not the advanced one, just the straightforward one. RHS 150 by 100. Oh, no, I've chosen square. I meant rectangular. That one. What's it? 150 by 100 by 5. That one. Universal column. Back to I. Column 356 368 129. UB. Oh, some beams are starting to appear. That's good news. 127 76 13. Rubbish. Rubbish. So the ignore is not remembered. I've got to click ignore for everything where it can't recognize the material. Metal deck, I actually know, I'm going to cheat here. I know exactly what that should have been, he says, because it came from Advanced 2 in the first place. So I'm going to cheat and I'm going to map that. I wouldn't normally. I can't think now, what is the metal deck? Actually, I don't know what that is. I'm going to ignore it. Can't think what it is today. If you ignore the material, it doesn't ignore the part, fortunately. It still brings the part in. There's not that many beams in this file, you'll see in a minute. But it's a lot of questions, aren't there? This is not unusual. This is quite normal. Try not to go too quick so I don't click on ignore when I could have mapped it to something proper. Lots of fun. See the progress bar at the bottom, nearly halfway there. It's going to shoot across the end. You don't have to wait till it goes all the way to the end. It usually shoots across the last bit. There you go. Right, it's finished. Bang, there you go. You might recognize this model if you've done any training with us. You saw a picture of it a minute ago. That's all the beams there were, but how many questions were there for these beams? I did map structural steel S275, which should have been all the beams, and yet it lasted loads and loads of times for what everything else was. So that's a bit odd. But look, that's what you get. That's the import. So it's got the beams. These are beams. If I double click on them, there you go. It's a beam. I can have a look at it. I can play with it and change things on there. So these are intelligent objects now, all of these in advanced steel. But take a closer look. Let's go back to my slides. There are issues with the results. There's a picture of what I just got. Some of these issues may occur every time, some of them may hardly ever occur, but there are lots of potential issues with these files that you've imported. Sections, particularly non-symmetric sections like channels or angles, can often be rotated. These issues actually often apply to any format, not just IFC. Sections can often be rotated. So that's user sections as well will be a classic one that will be rotated if you're not careful. But all of these came out the right way around in my model. Oh yeah, look at the bottom there. The concrete pad's moved. The plate is in the right place for the base plate, but the pad somehow is down too low. Don't ask me why. There are no bolts, no anchors. They're all missing. Look at the system lines going way past into that column, way past into the beam. What's this horn doing? It's shooting up into fresh air. They used to meet once upon a time. They don't meet anymore. And this obviously, when you're good practice in advanced steel modeling, they should meet, but they've all been shot all over the place. And actually, if you go into 2D wireframe, you can see they've also moved the system lines. The beams are in the right place. I have checked. They're in exactly the right place, but the system line is no longer top middle for these horizontal beam or the rafter. The system line has been moved to the middle. And that's no good because when you're doing your drawing and your dimensioning, it's important to have the system lines in the right places. When you do analysis, it's critical the system lines touch. And this file would be useless on both counts. Also, if you check out Project Explorer, for some reason it's created umpteen levels that have no sense at all. You can't have lots of identical levels. That's nonsense there. I don't know what's going on there. If you go into the beam properties, all those materials I couldn't recognize, they're just blank. It's not mapped onto anything. Even actually, although all the beams should have been S275 and I told it, yeah, that does equals S275, nothing in that model's got any material that's recognizable. And the same goes for model roll. IFC has no property for model roll, so it cannot be imported or exported. There's no effort to copy that through from the other file. That's always going to be blank. And you know model rolls are critical to getting the best drawings. So if you get a file where you didn't have one of those things occur, that's good luck on your part. It's nothing we can do about it, nothing we can do to stop those things occurring. It's all very technical in the files, like I say. It's not a switch we can throw. Those are issues that are likely to occur. If you get away without some of those, that's great. But you've got to look out for those issues. So that file, even though I've imported it, leaves quite a bit to be desired. And lastly, all the model rolls will be done, like we said. There are no intelligent drawings. It's got the pieces here. It's got the haunch pieces and this extra extra beam on the outside and the cuts and so on, but they are not intelligent. You can't edit them in a join box, so you haven't got the haunch properties, you haven't got anything else. If you needed to edit or adjust any of that, you'd have to do it the hard way. So IFC files leave quite a bit to be desired, and that's often have a lot of problems and don't import anything, but even if they do import, they're often not that great. So what alternatives have we got? Well, the BIM standard does not say you have to use IFC files. That's a misconception. Most people think, it's got to be BIM, so I have to provide an IFC file. It's the only choice. No, it's not. The BIM standards say you should offer data in the best possible exchange format you've got available. The best format you have available, not IFC. And then it says, at the very least, make sure you can offer an IFC if you can't offer a better format. So it's a last resort. IFC is the lowest common denominator, the last resort, probably the most useless of all the formats for import and export. The preferred formats, depending on what program you're going to go to, there are lots of different exchange formats, and some are better than others, but it seems to vary depending on which program you're talking to. So any of these formats would be better than using an IFC format. If you're going to Revit, Robot Structural Analysis, Advanced Design, Advanced Workshop, or Strumis, you should use SMLX files. Hands down, by a country mile, it's the best format for any kind of exchange. That format is completely 100% controlled by Autodesk, and it was created entirely with talking to Advanced Deal in mind. It can be changed and adjusted easily at will. There's no committees involved by Autodesk to make a better job of exchanging data with Advanced Deal. It will offer you functions. You can import intelligent joints. You can get all the data correct. Miles better than any other format if you're using one of those software, which are the only other software that can read and write that format. If you're talking to Tekla, obviously quite common, it's one of our competitors, then you can use CIS2 files. They're recommended as the best quality import-export from Tekla, but be warned, they still have the option to create BREPs, so you still have to ask the Tekla person nicely, please explore your options and do everything you can to make it export intelligent data, not just BREPs. If you're talking to a management control system, FabTrol, Strumis, or any other ERP system, you can use the SFR, the KISS format, KSS, or the PML file formats. Depending on the other systems, they can read those different formats. They're kind of like glorified bills of materials. They're not really 3D models encapsulated there, but you can get the data in and out quite accurately. StudPro is a common analysis bit of software, and the native format for StudPro is STD, and we can read and write that. If you still know anyone who's still trying to use StruCAD, even though it's been dead for 5 or 6 years, then the recommended format for StruCAD used to be SDNF files. Before I move on, let's have a look at a quick poll. I have got a poll here. I'm going to launch that. Please can you all indicate to me how often you receive your IFC files? Just out of curiosity, we're interested to know how big an issue this might be for you. Just click the appropriate thing on screen. 2/3 of you answered. There's still a third of you haven't answered. Please respond. It's only one click. Give me a few more seconds. I can see so over half of you have regularly get an IFC project, saying every few projects, so that's probably what I expected. But a third of you are saying you never receive them, so good for you, really. Always, if you have to exchange formats with somebody else, ask for one of those other formats, anything in preference to an IFC. Okay, that's long enough on that. Thanks for your answers. I'll close that poll. Right. So, having talked about all that with IFC files, there's a lot to take in and there's a lot of information there. And that goes for everything about Advanced Deal. So, this webinar is part of our efforts to help customers get them more out of Advanced Steel and to understand what's going on. But it's only part of the Advanced Steel experience. With Graitec, we always say there's 5 steps possibly to having full success with Advanced Steel. Hopefully most of you, if not all of you, have done some kind of basic training with Advanced Steel. But that shouldn't be considered the all you need or the end of the road. That's really just the start of your road with Advanced Steel. Once you've done the training, you need to implement Advanced Steel effectively. That can be really simple things like putting your logo on the drawings or on the bombs. It could be other things to do with the basic configuration. After you've done the basic implementation, there are things every company does differently. Every draftsman gives a different drawing for the same object. Every company has different standards. So we can implement your standards, we can customize the system, we can edit things inside the system. We can help you optimize Advanced Steel for your use. Practically every single company who ever uses Advanced Steel ought to look at getting some customization of the system to suit their preferences, even if it's just drawing styles. Drawing styles, obviously, major, huge output of the Advanced Steel is drawing still. And to get the optimized drawings, we can edit your drawing styles to reduce that editing time considerably. Yes, it's an investment in our consultancy to do that work for you, but if it saves 40% of your editing time, you'll rapidly recover any investment you've made. We can also manage other items in the databases, nuts, bolts, washers, special parts, custom sections, and so on, and we can help you collaborate with other people. If you're regularly importing, exporting data with Revit, then we offer a one-day course on how to import data successfully from Revit and all the ins and outs and complexities of what's involved there to make sure that's okay. Don't use an IFC file for Revit, use the SMLX, and so on. So there's lots of things we can help you with Advanced Steel. This is just one topic, one lesson that can hopefully help you. So now we have a few moments. I can take any questions if you have any. I did see one. I'll just check the panel. What have we got going on here? So I had one question actually right at the start. Is there any difference in compatibility with IFC 2x3 or IFC 2x4? My understanding is it won't make any difference to the import or export that you're doing. Obviously, X4 is slightly more recent. X4 is the only one I ever see anybody use. When you actually use Advanced Steel and you try and export an IFC, yeah, whatever. Right, that's better. It does have the option of IFC 2x3 or the MVD EM11. That's basically the MVD 11 is for welding robots, I believe. It's not of any use to importing and exporting files to Revit and so on. So always use the 2x3. There might be more up-to-date formats, but that's the one we read and write. If the file coming in is a 2x4, I don't think it causes any issues. I'm sure it just imports fine, or same as any other IFC. SDNF is somebody else asking. It's SDNF still detailing neutral format. Used to work with StrueCAD, so I now have made an IFC of my old computer to import to AF. Yes, I was told by the product manager, the Advanced Steel product manager who was in charge of the development, he said that SDNF was the best one for StrueCAD. I haven't done lots of testing in the last, this was a few years ago, I haven't done any testing in the last few years to see what the comparisons are, but certainly he said SDNF would give a better result. The best thing is to try all of them. If StrueCAD can export 3 of those formats, export all 3 and then try importing all 3, see what you can do better. It's not, SDNF isn't quite the StrueCAD native format, but it is supposed to be the best one. Okay, has anybody else got any comments or questions? Josh, Inda, I'm sorry if you lost sound some way through the thing. I think it's been all right for everybody else. I didn't change anything this end, so I hope you didn't miss anything important. Don't forget to download the handout. If you've got your panel on the right-hand side where people have been typing in the questions, got the handout there, download that so all the links are live on the PDF file, and you can click on those links to get all the extra information and download those other bits of software that I've mentioned. So that'd be a good thing. I've got a question. There's a lot of information, a lot of data in the document manager. I'm not sure if you're talking about the imported file. This file I've imported shouldn't have anything in the document manager because there are no linked documents. So I don't think that's what you meant. I'll just close that. In the Project Explorer, there is a lot of nonsense, as we said. So you could delete all of those because I don't think any of them do any good. Yes, you could delete them. In management tools, a lot of document manager and management tools. No, you can't really delete any information in here. It's all critical to the operation of Advanced Deal, especially anything in the table editor. Advanced Deal, everything, all the data in Advanced Deal is based on databases. So everything in the table editor which links to those databases is critical to the operation of Advanced Deal. I wouldn't ever delete anything. I don't even think there's a delete option in any of those normally. So it has to stay there. The only thing you might do, if you map something incorrectly to the wrong beam and you can find it, which is very difficult, if you can find the right line in the GTC mapping database, you might be able to delete that line. But there is, it's very challenging to find the right line. Yeah, so he's asking about GTC mapping. So the data for the mapping between the different files is GTC mapping. I don't think it even shows up with this link. No, it doesn't come up there. So you can't get that through document unless you do directly file open. So that's the database, but it's got quite a bit going on in here. It should be somewhere in that table, anything you've mapped, but it's very hard to find the right line in that table that you've just created because a lot of it's fairly nonsensical. So to find the right line that you've just mapped is quite challenging, but if you can find the right line, yes, you can delete it from there. But be warned, obviously, if you delete the wrong line, then you've lost the mapping of something else. So you want to be really careful because you think the ones I just did would be at the bottom, but no, they're not. So I would say at your own risk. I would always keep a backup before I ever touch anything in the database and ever edit anything. I always back up the database first. So if I don't like the result, I can put the original version back. You have a lot of box sections turned into UMP. Yeah, so if you have a look in here and try to find the right thing, you can see the standard, the GATC standard. Try and find the one that didn't make sense and see if you can recognize which line it is and delete the line. Or uninstall and reinstall, or find the original GTC mapping database from your disk so that you can copy it back off the original install download and get a clean file. And then you have to do the mapping again next time, but you'll have a chance to correct any incorrect mappings that have happened. When you reinstall or you get that original GTC mapping database from somewhere, then you'll have a clean thing with no mapping. So you'll lose all your mappings you have done, but at least you can correct any mistakes. Okay. At the end of this, when I log off in a moment, you'll see a survey. Please do fill in that feedback. We need the feedback to encourage us to do more webinars and to actually give us some ideas of what you'd like to see in webinars. So it's really important that you do fill in that survey. Please don't ignore it. It'll only take you 2 minutes or less, but it really helps us to keep giving you useful information on webinars and blog posts in the future. So you'll see that survey in a moment. I can't see any more questions coming up. So thank you for your attention today. I hope you found it interesting and useful. And that's the end of the webinar.